Okay, so I'm going to give you a very quick run through of how Ribble River Stuff has used SciMap to help us to prioritise the locations where we create new woodlands or where we restore or create hedgerows across the whole of the Ribble catchment. So that I've just said. And we also use SciMap quite a lot to engage with landowners and farmers. We find that it's a lot easier to kind of put our message across to farmers if they've got a nice map to look at, because they quite like a good map to landowners, we've found. So why do we use SciMap? To prioritise where we do certain works, to ensure that we kind of obtain the greatest cost benefit for the resources that we've invested in the woodlands or the hedgerows or whatever it is we're doing. We found that it can help us to secure funding, because there's evidence as to why we want to do something in a certain area. We've not just pointed at a map and said we want to create woodland here. There's a reason why. We found that it can facilitate partnership working, and I'll show you a bit of an example. And as I said, it can aid conversations with landowners and farmers, and it can lead to positive outcomes. Again, I'll show you an example of that. So first of all, I'm going to talk about a GIS-based tool and a model that we worked with Sim with to help us to prioritise the locations where we will create riparian woodlands for the benefit of rivers. So Sim created a SciMap type tool for us to do this, to help us to predict the relative risk of fecal indicator organisms entering the rivers, sediment from eroded topsoil entering rivers, and also the input of water from overland flows at quite a fine resolution across the catchment. And then we took the results of what Sim had made and used it to help us to identify priority stretches of watercourse where, if we created riparian woodlands along those watercourses, it's predicted that we'd have the greatest benefit at reducing one or more of these risk factors. So in the same way that SciMap works, Sim took a load of data that shows where the rain falls, how it's going to flow over land, and where it's going to pick up pollutants. And the output is pretty much what you see from the output of SciMap. So nearly, let's done some funny formatting there, nearly 500,000 points across the whole of the Ribble catchment, one for every 5 metres along every watercourse, and each point has a series of scores associated with them. One for the relative risk of fecal indicator organisms entering the river at that point compared to the relative risk of FAOs entering the river at all the other points across all the catchment. Again, the relative risk of sediment entering the river at that point in relation to the rest of the catchment, and the relative risk of water from surface runoff entering the river at that point in relation to the rest of the catchment. So that's nearly 500,000, 500,000 points with risk scores associated with them. The challenge was, how do we use this data to tell us where we should be looking at planting riparian woodlands? And because we also like ArcMap, we used an ArcMap-based tool to do this. So for each of the 3 risk factors, FIO input, sediment input and water input, we developed kind of a multi-stage process that would tell us which stretches of watercourse would have the greatest cost benefit for planting woodlands. So to put it simply, long stretches of watercourse where all the points, or a lot of the points along that stretch of watercourse, had a high risk of fecal matter entering, FIOs entering, or sediment entering, so on, a higher priority than a short stretch of watercourse which has a relatively low risk of whatever factor entering the river. And so the output of our model was a series of maps, one that would show us the locations where stretches of watercourse had a high risk of, or a risk of input of water from surface runoff, and the same for the input of FIOs into the river, and then also sediment from eroded topsoils. But as you can see, for each one of those, it's come up with loads of points. So the next challenge was, okay, this tells us a good idea of where we should be looking to create woodlands, but we can't create woodlands at all these locations. That's not going to be feasible. So where should we target first? So we then came up with kind of process to rank each of the sites based on how important they were for each of the risk factors. to, again, just to help us kind of focus on a smaller number of sites to begin with. And we also produced this map, which combined those 3 layers together and shows you where there's an overlap between of the different risk factors in different stretches of river. So you can see that the dark red blobs on the map, that's where it's predicted that if you planted a riparian woodland along that stretch of watercourse, you could reduce the amount of, you could reduce the amount of fecal matter, FIOs, sediment and water that are entering the river at that point. And any combination of those risk factors. And this is particularly useful when we're thinking about the funding sources. So it might be that the Environment Agency comes to us and says that there's money available for creating woodlands for natural flood management purposes, benefits. So you can see on the map that there's some sites where if you created a woodland, you could reduce the amount of water that's entering rivers, so have a natural flood management benefit. But as someone said earlier, you want more bang for your buck, so we can actually see that actually there are sites where we could use that funding to create woodlands to have an NFM benefit, but you could have additional benefits as well, so you're getting more cost benefit for your money essentially. So this is quite a useful tool in helping us to find sites where we're going to have predicted to have the greatest benefit by investing in creating a woodland at those sites. There's a bit of a tangent, but we applied the same process to the Keeping Rivers Cool data set. So Keeping Rivers Cool data set shows the level of shade on rivers, so we kind of flipped that, and so it showed the level of sun exposure on rivers, and then again went through the same process, or a very similar process, to tell us where we could create riparian woodlands to increase shade on rivers and identify locations where it's predicted to have the greatest benefit. So just some examples of where we've applied the work that we've done on this. So this is the Hyndburn area of the Ribble catchment. So it's an area to the south of the Ribble catchment, and they heard about this work that we've done, and they were quite interested to see the results for the Ribble, for the Hyndburn, and so we sent them the data just for the Hyndburn, and through looking at the areas that we'd identified as high priority sites for creating riparian woodlands, they saw a site that they recently bought the land, and but off the back of looking at these maps, they said we just bought this land. We'd very much like to plant a woodland on it because your map says, your analysis said that it's a high priority, and we agree. So that's a positive impact, a positive outcome that's just come from sending these maps to Hyndburn Borough Council. Michael's just left. We did this with Michael. So we have a collaborative agreement with Natural England in this area here of the Ribble catchment, where we have to visit so many farms this year. But there's over 300 farms in that area, so which ones do we try and visit first? So we took the results of our woodland prioritisation tool and kind of extracted out farms which had rivers on them, which we identified as priorities for creating woodlands, and then ranked the farms in order of importance for how, if they had rivers on there which were of high importance for creating woodlands, they were of a higher priority than those which didn't. And just by chance, the farmer from this farm got in touch with us for something, and we looked at this map. We saw that it was a high to medium priority farm that we wanted to visit, so we went out to their farm, we took this map with them, we showed them that there was a watercourse here that if we fenced it off and planted it up, we predicted you could reduce the amount of fecal matter that was entering that watercourse, and the same with this one, and there's also a high level of sun exposure on that watercourse. And we also overlaid just the normal SciMap flow path data, showing high, medium and low risk flow paths. And off the back of showing them these maps, they agreed to fence off and plant up this watercourse, and they've also agreed to plant a hedge on one of these boundaries that's currently just a fence, where there's an overland flow path, and also restore an existing hedge, so for natural flood management and benefits, and to reduce the amount of sediment that's washing down into the river. So that's a really positive outcome from this analysis we've done, but also just goes to show how a map is a really useful tool just when you're engaging with landowners. Another very simple example, we're engaging with a landowner over their countryside stewardship application. We showed them this map saying that this watercourse here, we predict that if you fenced it off and planted a woodland along it, you could reduce the amount of sediment and water that's entering that watercourse. And so they agreed to fence the whole of the watercourse off, not just that bit, and plant it up with trees, and that's gone into their countryside stewardship application. So that's, again, that's a very positive outcome. So as I said, we found that having this woodland prioritisation tool has been really useful for, as I've just shown, engaging with landowners and farmers and partners, which is resulting and will result in new woodlands being planted. And as I mentioned, it's quite useful for us in gaining funding, because there's an evidence of why we want to create a woodland where we say we want to. We've not just chosen it at random. Should you want to, you could repeat that analysis for wherever you work. I imagine you could do the same using the SciMap sediment and FIO results, or the Keeping Rivers Cool data, as I showed you. We have written a guide on how you can repeat this analysis if you're interested, and I'm always happy to show you. Very, very quickly, just another example of how we've used SciMap to help us to prioritise the restoration of traditional field boundaries for natural flood management benefits. This is for one of our partners, so the Forest of Bowland AOMB. They have a landscape partnership scheme here on Pendle Hill, and as part of their project, they are restoring a series of hedgerows and dry stone walls. And what they did is they had an ecologist go out and he surveyed all these boundaries across the whole of the area, and he kind of scored them based on their condition, and so whether they're a functioning hedge or a defunct or got gaps and so on, and then prioritise them based on which ones they think they should restore based on what their current condition is, but also their connectivity to other hedgerows and woodlands within the area. So the benefit that they'll have for wildlife if they're a functioning hedgerow.
So is that based on a field survey?
Yeah. Yeah. We're looking into doing that kind of thing with LiDAR, but we're just not there yet. As I imagine other people are as well. And then the Environment Agency approached them and said, we can provide some funding for you to restore these hedgerows and these walls, providing that they will have a natural flood management benefit. So then they came to us for help with this, and this is where we used SciMap. So we took their high priority hedgerows in this case, worked out their orientation, took SciMap, kind of classified them into high risk, moderate risk and low risk flow paths, and then worked out the direction of flow to enable us to work out which of the boundaries intersected were perpendicular to and therefore intersected these overland flow paths, and from that which of the boundaries intersected the high risk flow paths, and then from that we could pick out the boundaries which were, in this case hedgerows, which were in a poor condition, and so therefore if you were to restore them, if you were to fill the gaps in or just reinstate the hedgerow in general, it's likely that that hedgerow would then provide much greater natural flood management benefits, because it would do a better job at intercepting these high risk flow paths, and so reduce the amount of water and sediment that's ending up in rivers. And the colours don't come out that well, but hopefully from the previous map you can see there's much fewer kind of coloured lines on there, so that's given the AONB a much smaller number of hedgerows to focus on initially. So all those hedgerows will have benefits for wildlife, so the connectivity within the landscape, and also natural flood management benefits if they were restored. And again, it's a prioritisation process has happened, so the hedgerows which have currently have quite a long length of very poor condition hedgerows are a high priority, because if you were to invest money just in restoring that hedgerow, you've restored a long length of hedgerow, so you're going to have more impact restoring that hedgerow than if you're restoring a short one, which is in okay condition at the moment. So SciMap, the main way we've used it is to help us to target where we do work, or help partners to target where they do work, or look to where they should do work initially. You've always got to ground truth these things. And also to help us prioritise where we should look first, because we always come up with loads of sites where we want to do, so we need to kind of narrow it down, and that's the main way in which we've used SciMap, really. Very, very quick whistle-stop tour, but thanks for listening. Any questions?